This section, we're just going to talk about the elements, nothing more than basic element chemistry. If you look at the entire Earth, and by Earth I mean like the oceans, the atmosphere, the crust, the whole thing, most of it is made of just oxygen. Oxygen in some form makes up almost 50% of everything, and that includes the crust, you know, all the land and below the land, the oceans, and the atmosphere. One thing you should know about the atmosphere, though, the atmosphere itself is only 78% nitrogen and 21%, well, there's a percentage sign for you, oxygen. Oxygen is extremely flammable, so it would be bad if most of our atmosphere was oxygen. If we look at these 9 different elements right here, these 9 make up 98% of the Earth's crust, oceans, and atmosphere. But the bigger question is, what form am I discussing? Do I mean that oxygen, 98%, is in this form? I don't. There's many different forms an element can take. Let's take a look at the human body. The human body is 65% oxygen. And we're not highly flammable. So am I really talking about O2 here? No, I'm not. It's in some form. For instance, we know we have some O2 in our system as we breathe, but oxygen's also found as part of water. And we know that most of our body's made up of water. 18% of our body's carbon, 10% hydrogen, 3% nitrogen, and everything else is just a smaller percentage. By the way, carbon, hydrogen, nitrogen, and oxygen, we call these the elements of life. So carbon, hydrogen, nitrogen, and oxygen are the elements of life. One of the goals of this video is to help you understand the 3 different definitions of the word element. See, the word element could be exactly meaning the same thing as one atom. See, just one single sodium atom or one single calcium atom. It could just mean one. The word element could also mean a whole big bunch of the same atoms, such as the element gold. Well, that was starting to be gold, and then I changed my mind. Okay, so gold. I can talk about the element gold, and I mean a whole big bunch, and not just one. The word element could also mean some generic form. Like I was discussing before, we know that oxygen makes up a large portion of the human body, but in some form, not in any specific form. Now that we have 3 different definitions of element, it could mean, so here's your multiple choice, it could mean one atom, a whole big bunch of atoms, or some generic form. Look at the following sentence. Measure out 53 grams of the aluminum element granules. Wonder what form? Well, if you said this means a bunch of identical atoms, you picked the right definition. Multiple choice again. Do we mean one atom, a bunch of atoms, or the generic form? So here we go. The potassium element is very important for heart function. Well, in this case, if you guessed that I mean the generic version of the word, you are correct. See, potassium is found in this fruit. And here's a hunk of potassium metal, and clearly it's not in that form in our body because it catches on fire when you put it in water. So that would be bad. So potassium in some form is present in the body and important for your heart. So we use the generic form of element there. The silver element contains 47 protons. So by the word element here, do I mean one atom, a whole big bunch of atoms, or the generic form of the word element? Well, in this particular case, I'm talking about one atom. The properties of one atom in particular. Well, maybe I should not have the yes there. I lost my, there it is. Okay, that one's done. one atom. Now, you already know a lot of the names and symbols for these elements. You know that the elemental oxygen is O2. It's one of the big 7. Chlorine, easy enough, Cl. Uranium, U. And krypton, Kr. Please note, this letter must be capital and this letter has to be lowercase if there's a second letter. Now, sometimes this symbol comes from the Latin root, like iron. Iron's Latin word is ferrous, so we take the symbol Fe. Potassium's Latin is kalium, so we use the symbol K. That's Mercury's Latin name, which I always feel like I slaughter, so I'm not going to say it, but Hg, that's where it comes from. Sodium's Latin name is natrium. You don't have to know these, unless of course you want to possibly get a good extra credit point for them. But that's why some of the elements have symbols that don't seem to make a heck of a lot of sense. The goal for this particular part of the chapter is for us to identify how many of each atom is in the formula. This is the chemical formula for, do you remember? Glucose. But your biology teachers will be so proud. Anyway, so let's take a look. First off, we're going to start off with, let's see, carbon. Yeah, carbon's the very first one pictured there. So here we go. We're going to start with this one, carbon. So that's what the C means. It just simply means carbon. Now, this number down here is the really important number, the 6. What that means is there are 6 atoms of carbon in this particular molecule of glucose. Well, and actually all molecules of glucose happen to have 6 carbon atoms. So then our next question is, what was this? Well, if you said, that's hydrogen, Orton, you are right. How many hydrogens are there? There's 12 atoms of hydrogen in one glucose molecule. And then of course here we have oxygen. And oxygen contains 6 atoms of oxygen. So glucose has 6 atoms of oxygen. See, it's easy to count. Now, I would like to point out that these numbers, this one, and this one, these are called subscripts. And by subscripts, I mean these are sub, meaning lower than the line. Students will want to turn it in and say C6H12. That's not right. No, it's got to be C and then 6 down here, H, then 12 down here, O, and 6 down here. Subscripts below the line. Now let's see what you can do. How many copper atoms are in this molecule of copper carbonate? Well, because there's this invisible 1 there, we say there is 1 copper. How many carbon atoms are there? Well, there's a 1 there that we don't write down, just like in algebra, you know, we have that variable x. We don't put the 1 there. We know it's there, so there's 1 carbon. And how many oxygens are there? That's right, there's 3 oxygens. See, it's not so bad. Let's try another one. How many carbons and how many hydrogens? Well, the carbon, there's 3 carbons and there's 8 hydrogens. By the way, this molecule is propane. That's a really good extra credit question for me to put on the test. You should know propane in the same way you know water. You really should. Try this one. Oh, this one's bigger. So let's start with N. N is nitrogen. How many nitrogens are there? 1. Hydrogen. Be careful. How many hydrogens are there? There are 7. See, there's 4 hydrogens here, and there's 3 hydrogens there. So 7. How many carbons are there? Well, 2. And how many oxygens? 2. If you have any questions at this point, feel free to jot those down. I'll get to it when I can. Let's try another one. Okay, SN, tin. It'd be such a sin if you gave her tin. Well, there's an invisible 1 there, so there's 1 tin. Now this is very similar to the distributive property. See, there's a 1 there and there's a 1 there. So 4 times 1, so oxygen, there's 4 oxygens. 4 times 1, hydrogen, gives us 4. What this tin 4 hydroxide really means, if you take a close look at it, it means that another way I could write it would be SN, OH, that line represents a bond, OH, OH, and another OH. So we could add these up, or we could use multiplication, which of course is just fast addition. All right, let's try another one. Let me erase all the ink on this slide. Erase all ink on slide. There we go. Try this one. Oh, this one. Okay. Pause the video. See what you can do with this one. Well, there's this 1 there. So 4 times 1. So nitrogen is not 4 times 1. Oh, I'm so silly. It's 2 times 1. So there's 2. Now for the hydrogen, it's 2 times 4 hydrogens. So that makes 8 hydrogens. And then there's that 1 there. So sulfur is 1. So let me run through that again since I managed to completely mess up that first one. We'll try it again. NH4 is inside the parentheses. We know the 1's there. So 2 times 1 for nitrogen. So nitrogen has 2. 2 times 4 for the hydrogen. So hydrogen is 8. Sulfur, well, that's just 1. Shall we try one more? Oops, let me get this ink off the slide first. Again, you try it on your own and then play the video and see how you did. Well, for manganese, there's 2 manganese. Now here I have the parentheses thing going again, so let's start with chromate, chromate, well that is okay, alrighty, whatever, chromium. So 3 times 2 makes 6 chromiums, and then oxygen, 3 times 7, we end up with 21 oxygens. That's as hard as they get. Here's another way to write formulas going from the words to the formula. And these are pretty simple. It's just a reading thing. Let me show you how it's done. So here we have one molecule. It has 2 hydrogen atoms. So I'm going to write the hydrogen symbol, and because there's 2 of them, I'm going to put a 2 here. It has 1 sulfur atom. So sulfur's here, and we don't typically write the 1, so I can ignore it. And then we have 4 oxygen atoms, so O. And how many oxygens? 4. And you are done. This is actually the formula. You don't really have to know this, but it is sulfuric acid. You'll have to know that in the next chapter. Another way to write a formula is to look at the molecule. It says hydrogen's the smaller one, so this is H, and this one's H. And then it says oxygen is the larger one. So this one's oxygen, and this one's oxygen. So what would the formula be? Well, let's start with the hydrogen. If you started with the oxygen, I'm not going to mark it wrong, but let's start with the hydrogen since it was mentioned. Oh, look, first, hydrogen. And how many hydrogen atoms are there? Well, there's 1 there, there's 1 there, so there's 2. Then oxygen. How many do we have? 1 and 2. Does anybody remember the name of this guy? This is hydrogen peroxide. You know, that stuff you clean your ears out with after you get them pierced. Now we need the formula for this particular molecule that's given to us in words. So we have 1 carbon atom. So carbon, and there's only 1 of them, so I don't bother to write the 1. 4 hydrogen atoms, so hydrogen, and there's 4 of them, so we're going to put a 4 here. This is another one you should know. It's methane. Try this one on your own, and then push play and see how you did. Carbon's the larger one. So there's carbon, and there's only one of these guys. So one, there's only one carbon. And oxygen's smaller, so there's your oxygen, and there's only one of those. But we don't typically write the ones, so we should really have carbon monoxide. Don't breathe this stuff. Monoxide. Try this one on your own. Then push play and see how you did. All right, so we have one sulfur atom, so S, and I don't want to write the 1. Even though there's 1, we don't write it. 5 fluorine, so F, and I'm going to put a 5 there. Let's try one more. All of these are oxygens, so how many oxygens do we have pictured? 3 of them, so O3. And O3 is actually the formula for ozone. Now we're going to go back to counting. How many atoms are in each of the following? So we need to list them separately. Cu is copper, so Cu, and there's 1 copper. Oxygens right there. There's only 1 oxygen. And how many hydrogens? Well, there's 1 hydrogen. Try this one on your own, then push play. Well, potassium, there's 1, nitrogen is 1, and oxygen is 3. Iron is 1, carbon's 1, and oxygen is 3. This one gets a little more complicated. Gold only has 1 because there's a 1 right there. And this is where we're going to distribute this. So oxygen is 3 and hydrogen is 3. And this one's not as complicated. Cesium, there's 3 cesium. Phosphorus is 1 and oxygen, there's 4. If you didn't get any of these right, please let me know. I'd be happy to discuss them with you in class. Let's give this one a try again. We're just counting atoms. And trying to, there we go. All right, so count them up. Calcium is 1, and chlorine, well, there's 1. How many potassiums? 3. And how many phosphoruses? 1. There's 1 aluminum, 1 phosphorus, and 3 oxygens. Oops, should put an equal sign. That's supposed to be an equal sign. Okay, well, I'll just scribble it out. Start over. Equals. There we go. Pause the video. See if you can do this one. There's 3 magnesiums. There's 2 phosphoruses. And there's 8 oxygens. All right, give this one a try. Nitrogen, there's 1. Hydrogen, be careful, 7. Remember, there's 3 here and 4 here. Carbon is 2, and oxygen is 2. Just to finish up this video, let me remind you what we discussed. First off, the Earth is mostly made up of oxygen if you include the atmosphere, the crust, and the oceans. Oxygen also makes up the largest percentage of our body in some form. Which brought us to the word element, because the word element has 3 different meanings. It could mean a single atom like sodium, calcium, magnesium, chromium, zinc. It could mean a whole big bunch of identical atoms, or it could mean some generic form of the element. We also discussed that some symbols make perfect sense, like krypton, and some don't, like sodium, depending on where we take its name. Sodium takes its symbol from the Latin name natrium. Don't forget that second letter must be lowercase. And we learned how to count different atoms. Make sure that your subscripts look like subscripts. Up next, we're going to discuss different parts of the atom. You know, the proton, the neutron, and the electron.